dimensional vector space, let W1 and W2 with the subspaces spanned by these given vectors, respectively. We need to find the basis and dimension of W1, W2, sum of the subspaces, and the dimension of their intersection, right? So first, let's find the basis and dimension for W1. Now W1 is spanned by these two given vectors, right? Writing these vectors in the matrix form, for finding the basis, always try to get the matrix in echelon form. So for that, I need to get the leading entry for the row 1, right? And I'm already having 1 over here. For this to be a leading entry, I need to make this 2 as 0. So just multiplying the row 1 with negative 2 and adding its elements to the row 2. So applying the row operation, changing the row 2 and adding its elements to the row 1, but row 1 should be first multiplied with negative 2. So writing the row 1 as it is, and for the row 2, multiplying 1 with negative 2 we get minus 2 and adding this to 2 we get 0. Multiplying 0 with negative 2 we get 0 and adding this to 1 we get 1. Multiplying negative 1 with negative 2 we get 2 and adding this element to the 4 we get 6. So this is now the row echelon form, right? We are having the leading entry over here and below this leading entry we are having the 0 element, right? So let B1 be the basis. So therefore B1 is equal to 1 0 negative 1 and 0 1 6. So these forms the basis for W1. And the dimension of W1 is, how many bases are present? 2. So dimension of W1 is 2. Right? Let's move on to the second part to find the basis for W2. Now here W2 is spanned by these 4 vectors. So writing these vectors in a matrix form first. So for finding the basis, so first we need to get the matrix in a echelon form. So for that, we need to get the leading entry for the first row, right? This is your first row and I'm having minus 1 over here. What is the leading entry? It is the first non-zero element present in the row, right? But I need to make minus 1 as 1. For that, what I need to do? Just multiplying the elements of the row 1 with minus 1. That's it. So a very simple operation I'm applying here. Multiplying the elements of the row 1 with negative 1. Writing the other rows as it is. I must have all other entries below 1 to be 0. How to get 0 in place of 2? For that, just multiply the elements of the row 1 with negative 2 and add these elements to the row 2. Always write the number of the row which you are going to change. Always write here that number of the row which you are going to change. So I am changing the row 2 and adding these elements to the row 1, but row 1 should be first multiplied with negative 2. The notation separated with comma means we are adding the 2 rows with the operations applied on them. So writing the row 1 as it is and changing the row 2. Okay. 1 multiplied with minus 2 we get minus 2, adding this to 2 we get 0. Minus 2 multiplied with minus 2 we get 4, adding this to 2 we get 6. Minus 2 multiplied with minus 2 we get 4, adding this to minus 1 we get 3. Similarly, I need to make 3 to be as 0 now. For that, multiplying the row 1 with negative 3 and adding its elements to the row 3. Same. And now to get 0 in place of 2, for that, just multiply the row 1 with negative 2 because I am having 2 over here. Multiplying the row with minus 2 and adding these elements to the row 4. So this becomes the leading entry for the first row. Next step, we have to get the leading entry for the second row. I need to make 6 as 1 first. For that, what should I do? Multiply the elements of the row 2 with 1 by 6, right? So the next row operation is a simple one. Multiplying the elements of the row 2 with 1 by 6. Writing first row as it is and changing the row to 0 multiplied with 1 by 6 we get 0. 6 multiplied with 1 by 6 we get 1. 3 multiplied with 1 by 6 we get 1 half. Right? Okay. Now to get 0 over here and here, I need all other entries below this to be 0. We always take the advantage of the row having the leading entry. Right? So to make 0 over here, just multiply the row 2 with negative 6 and adding its elements to the row 3. 0 multiplied by minus 6 we get 0 and adding this to 0 we get 0. 1 multiplied with minus 6 we get minus 6, adding this to 6 we get 0. 1 half multiplied with minus 6 we get minus 3, adding this to 3 we get 0. And now to make 0 in place of 3, just multiply the row 2 with minus 3 and adding its elements to the row 4. So now all the entries below 1 is 0 now. So I'm marking this with blue color. This is just for remembrance that we are getting leading entry for the first row to be here and getting the leading entry for the second row to be at this place. Right? Now for the third row, I'm not having any non-zero element. Right? So there could be no leading entry for the third row. For the fourth row, just try to make this as 1 by multiplying the elements of the fourth row by 2 divided by 9. Up to this is okay. But to have more beautiful entries, we can also change this negative 2 to 0. For that, I'm going to change the row 1 and adding its element to the row 2, but row 2 should be first multiplied with 2 so that I can get 0 over here. To avoid this negative entry, I'm interested to change the row 1 again by adding its elements to the row 4, but row 4 should be first multiplied with 1. Just apply the operation in such a way that there should be no disturbance to the leading entries, right? Then again, to avoid this fraction, what should we do? Just multiply the elements of the 4 with minus 1 half and add these elements to the row 2. You get 1 over here. Alright, one thing more, just interchange these two rows. So interchanging the row 3 with row 4. This is the notation for the interchanging of the rows. So I'm getting the leading entry this to be for the first row, leading entry this to be for the second row, and automatically we have got the leading entry for the third row also by interchanging the rows, right? So we are having now the 3 non-zero rows. Let B2 be the basis for W2. So the bases are 1 0 0, 0 1 0 and 0 0 1. And how many elements the bases are containing? 3. So the dimension of W2 is equal to 3. Next, now since W1 is spanned by these 2 vectors and W2 is spanned by these 4 vectors. So therefore, W1 plus W2 is generated by all these vectors. Let's write all these vectors in a matrix form. So many rows, right? That's okay. Let's get the leading entry for the first row. That is this one. I need to make all other entries to be 0. So let's first make this 2 as 0. For that, I need to change this row 2 and adding its elements to the row 1. But row 1 should be first multiplied with negative 2. Always try to get the advantage of the row having the leading entry, right? So writing the operation, I need to change the row 2 by adding its elements to the row 1, but row 1 should be first multiplied with negative 2. Writing the first row as it is because we are going to change the row 2. 1 multiplied with minus 2 we get minus 2, adding this to 2 we get 0. Yes, we got 0 over here. 0 multiplied with minus 2 we get 0, adding this to 1 we get 1. Minus 1 multiplied by minus 2 we get 2, adding this to 4 we get 6. So we got now 0 in place of 2. Getting 0 over here now. For that, just multiply the row 1 with 1 and adding its element to the row 3. Alright, now to get 0 over here, for that just multiply the elements of the row 1 with -2, very good, and adding its elements to the row 4. And now getting 0 in place of 3, for that just multiply the elements of the row 1 with -3 and adding its elements to the row 5, right? So applying this operation, 0, 0, 0. Likewise, to get 0 in place of 2, we just multiply the row 1 with -2 and add these elements to the row 6. So we are getting row 6 to be as 0, -1, 4. Now this becomes our leading entry for the row 1. All other entries below 1 is 0. For the second row, I'm already having 1 over here, but I need to get 0 in place of all these entries, right? So I'm going to take the advantage of the row 2 now. To get 0 in place of 2, just multiply the row 2 with -2 and adding its elements to the row 3. Changing the row 3 by adding its elements to the row 2, but row 2 should be first multiplied with -2. So this is 0 now. Getting 0 for 2 and now getting 0 in place of this 2. For that, again we have to multiply the row 2 with -2 and adding its elements to the row 4. And we get the result to be as 0, 0, -11. Already I'm having 0 over here, so write this as it is. And now to get 0 in place of -1. For that, just multiply the row 2 with 1 only and adding its elements to the row 6. So we have changed the row 6 by adding its elements to the row 2, but row 2 should be first multiplied with 1 only. I need to make this to be as 1 first. For that, just divide the row 3 with -11 or multiplying the elements of the row 3 by -1 by 11. So we get 0, 0, 1, right? Now we get 1 over here. We need to make all these 3 to be 0. We always try to get the advantage of the row having the leading entry. To make 0 over here, we multiply the elements of the row 3 with 11 and adding these elements to the row 4. 0, 0, 0, and the last row is I'm having 10 over here. To make this to be as 0, we multiply the row 3 with -10 and adding its elements to the row 6. So this becomes 0, 0, 0. So I'm getting all the entries to be 0 below this 1. If possible, try to avoid these negative entries and also to get 0, 0 above this leading entry, right? I need to change the element of the row 1, right? For that, just multiply the row 3 with 1 and adding its elements to the row 1. And now to get 0 over here, is it possible? Let's check. If I multiply the row 3 with -6 and adding its elements to the row 2, I can get 0 in place of 6. But other elements should not be disturbed. So this is our echelon matrix with the beautiful entries present in it and having the non-zero rows at the top and the beautiful leading entries having 0 above and below those. So these are the non-zero rows. So let B3 be the basis for sum of W1 and W2. So we are getting the unique basis of W1 plus W2 as 1, 0, 0, 0, 1, 0 and 0, 0, 1. So this is basis for sum of the subspaces W1 and W2. And how many elements are present in the basis? 3. So the dimension of sum of the subspaces is equal to 3. Now to get the dimension for W1 intersection W2. A very well known result is that since dimension of W1 plus W2 is equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. We have got the dimension of some of the subspaces to be equal to 3. Dimension of W1 is 2. Dimension of W2 is 3. So just putting these values. So this is 3 equal to dimension W1 2 plus it is 3 minus the dimension of W1 intersection W2. So this is 3 equal to 5 minus the dimension of the intersection of the subspaces. That further implies just take this to the other side. We get the dimension of intersection of the subspaces to be equal to 5 minus 3, that is equal to 2. Alright, thank you, stay blessed.